my students. Today we're going to be talking about proportions that occur in right triangles that have similar right triangles within them, which is like mind-boggling, right? Okay, well, before we can talk about proportions that lie within a right triangle, we need to go over something called the geometric mean, which is what we'll be using to solve for missing side lengths of right triangles that contain similar right triangles within them. Okay, so the geometric mean, if a over x equals x over b, then x is the geometric mean between a and b. So if you have a proportion, because we have two ratios, right? If you have a proportion and there are two parts of the proportion that are the same, which the parts that have to be the same, one denominator has to be the same as one numerator. So if that is the case, then you are finding the geometric mean. Like if you guys see here, the x lies in the denominator and numerator of my two ratios. Okay, so that gives me the hint that we're finding the geometric mean. Okay, so we're going to first start off by figuring out how to solve when we have a geometric mean. So in example 1 and 2, we're going to find the geometric mean between two values. So in example 1, it'll be 4 and 18. And in example 2, we'll be finding the geometric mean between 2 and 20. So whenever you have a proportion that's set up like this, you are finding something called the geometric mean. Okay, so let's go over how we solve example 1. Okay, so I kind of have that set up again. When we have a geometric mean, sorry guys, don't be doing this. Okay, it's freezing again, stop. Okay, we're there. Okay, so again, when we have the geometric mean, we're going to have two ratios that equal each other, which means we have a proportion. And always when we have a geometric mean, two of these parts are going to be the same, and it will always occur along a diagonal. Okay, so this represents the geometric mean between A and B. Okay, which A and B are going to be the two numbers that we're trying to find the geometric mean between. Okay, so let's get going on example 1. So example 1 says, what is the geometric mean of 4 and 18? Okay, so the two numbers, those are going to be either the A or the B. It doesn't matter which one is the A and which one is the B. It's kind of up to you. Okay, so I'm going to make the 18 the B, and I'm going to make the 4 the A in my formula. Okay, and then the x's are always going to remain as x. So the geometric mean that we're solving for will be the x. So we always leave those as the x's. So don't touch the x's, or that's when the demon cats might get you. So watch it. Okay, let's set it up. So I'm just going to fill in my a and my b. The x's will stay the same. Okay, let's set up this proportion. And then after we set up the proportion, how do we solve a proportion? We do cross multiply. So guess what, you guys? We're going to be cross multiplying this entire section as well. So if you'd like to cross multiply, well, this is basically your unit. So we keep cross multiplying over and over and over. Okay, so my my B is going to be the 18. So I'm going to write the 18 here. Okay, and my A is the 4. So I'm going to write my 4 right here. Okay, and nothing can be reduced down, so I'm just going to go ahead and start cross multiplying. Okay, so I'm going to start by going this direction, so my x's. Okay, and again, these two are always the same, so just watch that. Okay, so x times x will give me an x squared. Okay, and that will equal... Let's go the other direction. So, I don't know. I'm going to use this color. Okay, 4 times 18. Okay, which, let's see here. That's going to be, I think, 72. But again, if you don't know, it doesn't hurt to check. So, 18 times 4 is 72. Look at that. All right, and from here, we just need to solve for x, which, if you guys remember, whenever we have a square in a problem... Do you remember how we undo a square? Because I really want to find x, but currently that squared is getting in the way. So how do we deal with the squared? Well, the opposite of a square is to square root both sides of your equation. So I'm going to square root both sides of my equation, which the square and the square root and the square will cancel out. So I'm left with x equals. Now, don't forget, you guys, whenever you square root both sides of an equation, technically a plus or minus will appear. Now, when we're finding a geometric mean, this is a type of average, okay, which averages typically are not negative numbers. Guys, so technically when you square root both sides of an equation, a plus or minus should appear, but in my final answer, the negative won't make sense, so I'm only going to include the positive in my final answer. So this will be the square root of 72, which is 72 a perfect square? It is not a perfect square. Oh no. So what do we have to do when we don't have a perfect square? You guys are right. We got to do that factor tree. We got to break it on down. Let's break it on down. Okay, so I'm going to find two numbers that will multiply to be 72, which one option is 8 and 9. Okay, that's what we didn't multiply it there, but 8 and 9, you could have also said 4 and 18. Okay, so whatever floats your boat. Okay, 8 will break down into 4 and 2, and 4 will break down into 2 and 2. And 9 will break down into 3, sorry, that's 3, and 3. Okay, so for my final answer, don't forget, we're not going to include the negative because a negative average in this sense does not make sense. So we're going to have x equals, okay, we're going to have our square root. Okay, now, I am looking at the ends of the branches. Okay, so if a number breaks down, I am not looking at it. Okay, like the 72 broke down. I have these two lines coming from it. So I am not going to look at 72. The 8 broke down, so I don't look at 8. The 4 broke down, so I don't look at the 4. The 9 broke down, so I don't look at the 9. Okay, you're only looking at the numbers at the ends of what I call the branches that we're talking about a factor tree. Okay, these are what I call the leaves, the numbers that don't have any branches coming off of them. Guys, so I'm trying to find some cute couples that get to leave the house to go on their math date. Do you guys spot any couples, any pairs of numbers? Well, I see a pair right here. I have a pair of 2s. I could have also circled like these pair of 2s or like this 2 and that 2. It doesn't matter which pair I circle, but I'm only allowed to circle 2 at a time. Okay, I also see a pair of 3s. Guys, so every time you circle a pair of numbers, only one of those will hop outside my square root. Okay, so for the pair of 2s, we have 1 2 will hop out. And for the pair of 3s, we'll have 1 3 hop out of the equation, or the square root. And remember, if you ever have more than one number that hops out of your square root, you multiply it. So I'm going to multiply the 2 to the 3. And do you guys see any lonely single numbers that don't get to go on their math dates? It would be the 2. The 2 is the lonely single number that has to stay inside the square root. Okay, so for my final answer, I'm going to get x equals 6 times 3, which is 6. And I don't have any other numbers, so it'll be 6 root 2. And guess what, you guys? That's the geometric mean of 4 and 18.